Okay, let's give you guys some practice. So find the limit of each of these functions. So here, if you look at this x squared sine squared, I've already given an explanation as to why this function looks like this. So let me just give you a quick reminder. So if you're trying to find out what the function will look like, so y equals x squared sine of x. So x squared will look like this, and remember, I've already given this this explanation. I'm just quickly giving you a revision. So this point here moves up to here, this point here moves up to here, this point here moves up to here. This is -1 because let's say at a here, put a into here. Sine of a will be -1 because it's at the lowest point of the sine graph, and then -1 times a squared, that would then jump to the negative version of the x squared, if that makes sense. So this point here moves down to here, this point here moves down to here, this point moves down to here. 0 times anything would be 0, so the point all along here will remain at 0. The moral of the story is that your final graph will look something like this, and I've already given an explanation as why this is the case. So I'm expecting you to be able to sketch this function. So to do this, as x heads towards 0, so you've got to head towards 0 here because 0 is here. But the thing is, you've got to stay on the function. So approaching 0 from the right hand side, you can see that you're approaching a height of 0. And then approach 0 from the left hand side, you can see that you're heading towards a height of 0. So the limit is actually 0. So for this one, y equals x looks like this, and you've got your sine graph looking like this. Combining the two, the function will look something like this. So what is the limit as x heads towards 0? So 0's here, so you've got to head towards 0 like this. But the thing is, you've got to stay on the function. So moving along the function, you can see that you're heading towards a height of 0. You can see that you're heading towards a height of 0, so therefore the limit here would be 0. And then for this one, as x heads towards -infinity, -infinity is all the way down here. This is -infinity, this is +infinity, this is 0 here, but we want x as x heads towards -infinity. So you put your pen nib here and then head towards -infinity, well, head towards all the way to the left. So put your pen nib here and then move along here. So you can see that you're heading towards a height of 1. So therefore, the height of 0. So the limit here is actually 0. So for this one here, what is the limit of, well, 1 over x looks like this, sine of x looks like this. Combining the two, it would give you this. As x heads towards +infinity, 0's here, -infinity's all the way to the left, +infinity's all the way to the right. So it's saying as x heads towards all the way to the right. So you put your pen nib here and then head towards all the way to the right. Dead on 0, it breaks down because of this bit here. So all of a sudden from here we jump to the right hand side and then continue on our journey. So we're moving all the way to the right, and then as you head towards infinity, you can see that you're heading towards a height of 0. And then for this one, remember for this thing here, 2 to the power of x looks like this. This is 2 to the power of x. Suppose you have a function like this. If you apply this transformation, negative, it will then give you the negative version, meaning this transformation flips it. So this graph here would now look like this. So that's where this thing is. You can see this has a height of 1. Well, anyway, this whole function here will look like this. And then it's asking what is the limit as x heads towards infinity. So infinity is all the way to the right. So you would put your pen nib here and head all the way to the right. As you're moving to the right, you can see that you're heading towards a height of 0. So the limit here is actually 0. And then for this one here, as x heads towards 2 pi, I don't know where 2 pi is. Let's just guess 2 pi is somewhere over here. So we've got to head towards 2 pi from the right hand side and from the left hand side. So So let's just imagine 2 pi somewhere over here. So we're heading towards 2 pi, and I don't know where it's going to end up. And then from the right hand side, I don't know where it's going to end up, but it's going to be somewhere around here. But the thing is, if you look at this block, if you put 2 pi into here, sine of 2 pi, remember sine graph looks like this. 2 pi is 0. So so this block here would be 0, and then you put 2 pi into here, square root of 2 pi. I don't care what this is, but it's going to be this thing times 0. Well, anything times 0, it will be 0. So the point is that 2 pi, me not knowing where 2 pi is, let's just guess it to be somewhere around here. So when you're heading towards 2 pi, you're actually heading towards 0, because this block will be 0, this block here will be root 2 pi, and when you get root 2 pi times 0, it would be 0. So the limit is actually 0. The limit is 0. Okay.